Sherian. I'm very happy to introduce Blerim Lataj as a third speaker. Blerim started his career 2003 with Bühler. He made an apprenticeship, mechanical apprenticeship program, followed by a higher education in corporate processes. Blerim, for the last 10 years, has built up an expertise in maintenance processes and maintenance structures. So his presentation is absolutely in line with the previous, talking about maintenance and reliability. Welcome, Blerim, for your presentation.
Thank you very much, Martin, for the introduction. I think you everything mentioned except of my hobbies, which is bike and family and kids. And I now will share my presentation. Just give me 1 second. All right, maybe I have to do it somewhere different.
In the meantime, I will tell you, Blerim will go for also introducing us in predictive maintenance, but giving us facts and figures. This is followed by the previous presentation.
So, excuse me. Okay, now I think it works. Can you see my screen, Martin?
Yes, go please on presentation.
Ja, okay.
So, okay.
Nein, jetzt hast du ihn gerade rausgekriegt.
No, now you kicked him out.
Sorry, you see, technique is wählen, der oder der? Der. Good. Okay, I think now it's good.
Perfect. Now you go for presentation.
Very good. And finally, we're there.
Done.
Okay.
Yeah.
Very good. Thank you very much. And sorry for this. It was the first time for me using this new tool. Thank you very much. My name is Blerim Lataj. As Martin mentioned, I'm Business Development Manager of our CMMS system. And I would like to start and continue a little bit on Johan's and also Erkan's presentation. They talked many times about predictive. I will start in the beginning, show you what was before predictive came, how that develops. Also, we have some case studies done on some flour mills and to see how that goes, and also to show you a little bit what we are doing, especially here in random of predictive maintenance with CMMS software. Before looking to the CMMS, we should understand how the revolution of the industry in general grows up. Here also you see many times this on some magazines, and also sometimes on some posters that many customers or companies are now talking about Industry 4.0 and so on. Let's start with the basic, Industry 1.0, which was around 19th century coming up, especially mechanization, steam power generation, so the first plant starting to make energy consumption for the humanity. Later, around 1870, Industry 2.0 came in, where mass production, especially, you maybe remember Henry Ford, assembly lines in automotive industry to be more efficient came up. This was the Industry 2.0. Around 70s, then Industry 3.0 came up. This also maybe not everyone knows, where the automation were introduced, and also computer and electrotechnic starts to use more and more, and also here, for example, change a little bit the work structure of an employee. Today, we are fully now in this Industry 4.0 timeline, especially here when you look to the Internet of Things, or to the Internet connectivity and network, and also, of course, looking forward to the next step, to the cyber physical systems. So this is 4.0, so connected devices together. Now the same we also have in the maintenance industry. The revolution there was also a bit with a different timeline, as you can see below here. We should maybe also use these terms because they are officially approved, and also some of them maybe speaks reactive maintenance, preventive, corrective, just to be sure that we all know the same languages. Let's start with the first one, and also maybe still the most common one, the reactive or corrective maintenance. So also here started in the before the 1970s, so things get broken, you simply fix that. Around 70s to 80s, when the first computer was introduced, that's why also CMMS, the term is called that way, but later more on that, preventive maintenance was introduced. So planned schedule overhaul or maintenance work supported by a system on computer device. And this is also still most of the time the standard for these days. The next step was also here coming together with the automation, the condition monitoring age, where condition monitoring, for example, by running hour, and running hour is still one of the key performance indicator these days. And also maybe you take a look then back on the history of the failures and analysis to be more on the safe side. This is maintenance 3.0 or condition monitoring. And today we talk all about maintenance 4.0, the predictive maintenance. What is that in term? It's of course the machine learning where we use sensors. We have seen the presentation before. We take live sensor data and you make a prediction, but also it is cloud connected. So we're using your devices or a tablet, for example, to do these maintenance tasks directly on mobile devices and also over the cloud transmitted. Now, after 4 came 5. What is the next step? Sure, maybe not yet in our industry. This is the prescriptive maintenance, which is fully process-based. And also, yeah, we can say it's simple, heal yourself. So machines know exactly what to do. This is more or less, as I said, maybe not yet in our industry, but if you look to the automotive industry, usually you have there one maintenance operator, and the machines have some certain backlog where they have, for example, when this happened, you should do this error, or you should reset the complete configuration and start from there. So that's the future. But let's stay still on maintenance 4.0. I think that's the topic for today. Good. Now to bring that maintenance topics a bit more into practice, I found a very nice slides from also a mechanical engineer. This guy, he made 3 plots, as you can see here. The more left one, then a middle, and here the right, which is the predictive. You see the terms from the slide before here on the right side. So CMS or corrective maintenance clearly is here the left, where you have nothing. You just run under pressure. You run random, unexpected stress, and sometime without any plan. The middle one, still the golden middle, I think, is the review maintenance, where you do this plant or preventive maintenance. As an example here, car inspection, yearly inspection. And the right one is the predictive, where you have certain intelligence, some certain sensors, which tell us the right algorithm to do the jobs or the right maintenance task here before they failed. Now you see one is missing, is this condition monitoring. And why not doing already this? Because maybe we don't have all this maintenance 4.0 in-house. Maybe we can already take here, for example, a simple calendar interval and run that on running time. This is the term. Now, of course, I think also in the slides before we have seen it's a cost and benefit question. What are you willing to invest, maybe to go in a further predictive view, or you stay in the middle, or you maybe have not that budget to even think about predictive or preventive maintenance. It's all a question about the cost and benefit, of course. Now let's break this down a bit more to see how the methods could be used in a plant organization. You have seen the colors of the previous slides. When we talk about breakdown maintenance, we see here corrective breakdown maintenance ad hoc. So you have nothing, you just go risk, and maybe this is the worst case. The next step from breakdown maintenance is reactive maintenance, where, for example, has some multiple failures on a flap, which has a hole. You fix that flap maybe, but you know, sometime in the future, in the near future, you must exchange the complete flap. This is a reactive maintenance. On the blue chapter here, these are the planned maintenance. Also here we define 3 different variations. The first one is the periodic maintenance, so the daily checks, the weekly, let's say the multiple equipment which you have in a plant. where maybe it doesn't make sense to make here a proper maintenance system, or to install it in the proper maintenance system because of overkilling all the tasks which you have to do. So you're just collecting done. Maybe it does not make sense. The opposite of that, and all to the millers I speak now, is the planned maintenance. So the big stuff where you have to change the rolls all 2-3 years, whatever, and you need to stop production. You need to coordinate that with the maintenance supervisor, with the team leaders, with the plant maintenance supervisor, and also, of course, with the millers. Then exchange the rolls, and maybe this will take you 4, 5, 7 hours, whatever. So the big stuff. And for all of the rest, we use the preventive maintenance, which leads, let's say, from 1 month maintenance time to 1 year, all of the other plant activities. Either doing it by calendar, or maybe also better on condition-based running hours, for example, with our automation software, Wincos R2 or Mercury in combination. And the future, what we are talking also these days, is the predictive aspect. And here I have to say what I have seen the last 10 years, that we are maybe not yet there. Maybe we should focus on predictive maintenance on, let's say, on the key machines, for example, on the sifters, on the rollers. But trust me, not every sensor or not every machine like magnet will have a sensor in the near future, because really it's a question of cost and benefit. Now, if you ask me what is the right method for my plant, I would say all of them. You have some certain equipment which you only run reactive or corrective, especially on the electronical equipments or components. Then for the plant maintenance, most of them, and focus really on the predictive maintenance, for example, on the roller and on the key machines. Good. We did a case study last year of this so-called OEE term. And my colleague Dirk will talk tomorrow a bit more what is OEE. Just in general, it's the production time versus the real efficiency time what you have. Here you see a cost calculation. It's a very simple one, just income based on income. It's a 500-ton flour mill, which we split up here into bran and flour, and 240 days work. So that's based on German facts. And what we see out of this simple calculation, just a regular plant, which is running 240 days, will increase here 7,300 euros of breakdown cost per hour. Now, let's say if this plant is running 24/7, then you maybe have, let's say, 3 hours breakdown, and you have no more time. The problem there is that the input time is gone, and you maybe not, you're not able to run on Saturday or on Sunday this 3 hour which is missing, and maybe you cannot deliver your customer. Why is that important? Because when we look on the cost structure of a flour mill in general, we should understand as well that 75% of all the costs is the raw material. And break it down on capital cost, distribution, and looking especially in our case where we are on the production is about 10% what we have there in our hands. The staff is about 4 to 5%, energy is about the same. And focusing on the maintenance topic, also again for this 500-ton flour mill, you see here, I don't have that much budget where I can play around and mess up a lot. And the problem here again is poor maintenance leads automatically into more energy consumption. So if my rolls are not good or the sieves are broken, I need also more energy. So I will have here an increase of costs in maintenance and in the energy section. And that's maybe not really what we want to focus. Good. Last year, we all had this special situation with Corona. So to be honest, I was not that much traveling last year. So what we did there, we asked our customers with a survey about the maintenance cost. And also here a KPI in our language is the cost per ton. I think most of you guys know that. So here we asked the customers which are using some systems like ProPlant or similar systems, what are your costs in tons? What we see there that 2/3 is related to spare and wear parts, and 1/3 of this cost is related to manpower. Now we break that down, and in average we can say that the cost calculation for plant up to 10 years is €1.50 to €2.50. Also again for this 500-ton example, as you can see. And plants older than 10 years has a cost structure per ton of €2.50 to €4.50. Just 1 second. Now let's bring that again into relation. Then also the customers which are using some preventive or planned maintenance in general, we can say, and the other one which are only driving corrective. As you can see here, we face about €396,000, which is more or less is 400,000. And now here, by using preventive or planned maintenance organization, up to 50% you can save off this cost. So it's not that much, but it's better than the opposite, where you have no more budget around to focus on the next. So where I stopped, I think it was here on the synopsis, where we have a new plant, and this is in average what we also see, that the new plant usually 4 to 5 years, it runs really smoothly. After the fourth and the fifth years, maybe also there will be some organization change. You get maybe a new supervisor, which is more cost driven, and that also the first equipment starts to be failing because of poor maintenance. So what happened then over the other following years? So after 8 to 9 years, you will maybe focus then the budget, which is, for example, here €1.50 per ton, and the cost, which is €2.70. And now bring this in relation, you will have here a gap up to 5% maintenance budget, which is going down over the years. And on the opposite, the costs are increasing by that double time. Maybe this is leading after 10 years to more and more, where you have to ask yourself, does really a plant make sense to operate with so much cost on the maintenance topics, and focusing on this direction. Good. So what is other challenges what we are facing in a daily operation of a flour mill? Listen again to our customers for over 10 years in experience. We see that the maintenance schedule for most of them, especially for them which are not using a system like ProPlant, then to keep the scheduled time, it's also a big challenge, especially when we see here that 40% of all the maintenance tasks are delayed always. That the maintenance task is planned, you have a maintenance schedule, but you cannot stop the production, because this leads also to the next point, the communication between mill managers, operators, plant maintenance organizations, storekeepers. This is a very important topic, the communication of the different roles, which leads also to the next topic, the specialists. We are more and more losing specialists, which maybe can change a sifter or know how to do the maintenance on the roller mill, how to change that this is also going to be lost. And especially the young generation, you know, they are more focusing on working on the office from 8 to 5, so that they get the right people in position. Then the next one, the priority. Now, if you have more corrective maintenance, what are your priorities? Which maintenance tasks you focus? Maybe first in the mill, then in the cleaning section, and maybe later then on the rest of the equipment. I forget also the spare parts topic. This is also a very important these days. We have seen there one of the third of the costs is related to spare parts. If I don't have a good spare parts organization, or maybe a clear system that maintains all my parts, I don't know what are my costs at the end. So cost calculation in general, you have hours, human hours, operation hours, and spare parts. And this you have to bring into 3 to see the complete labor costs. And maybe also in your region, followed by audits. These days, EFS, BRC, ISO audits, which you have to follow certain acceptance to get this certification also. And the reality, we all love to speak about food safety, traceability, sustainability, SOS, and be honest, open your machines, see how they look like, and we will maybe focus a little bit these kind of pictures. Listen, to all of these maintenance topics, what we discuss the next days, predictive, corrective, they are all tools, in my opinion. Also predictive maintenance. They will tell me what is defect, which motor is too hot, but they never will do a job for us. That's why key is your operation, your team, your employees. These are the keys to avoid this kind of pictures which you see in front of you. I don't want to scare anybody with these pictures, but that's the reality, and I have hundreds of these pictures. Good. let's see how we can avoid. Let's talk about CMMS. What is this CMMS? It's very simple. Computerized maintenance management system, an old term from the 80s. You have seen in the previous slides that was a revolution in that time. Today, they are also called more and more EAM, Enterprise Asset Management System. This describes really the schematic support of maintenance procedures by software. That's the term in general. What are equipments, or what are the functions of such a CMMS system? You see here, the major of them is the asset and equipment management system, the complete machines which you have in a plant, which is maybe 200, 300, 400, 500 machines, to collect all of this data. And this is also, by the way, the biggest challenge, to integrate this data, which will maybe take you a half year or a year or maybe over years to implement this and complete that CMMS system. Then what you have to focus is also a preventive maintenance system. So a CMMS system should also have here a clear maintenance planning over the year, which all the machines are included. But don't forget about the opposite, preventive, corrective. So it also should allow you to interact immediately when there is a breakdown, to register that you have a complete pictures of all the investments. Then also part of a CMMS is always an inventory management system. These days, maybe you have SAP or similar system where you can interface, or you can make a connectivity between that, but it's also part of it, inventory system or a warehouse management software. And the last one, which is especially these days coming up, is the documentation, sanitation, where you have all the paperwork physically then on digital platform. Good. Our CMMS system is called ProPlant. We say it's a service management system. This organizes all the maintenance schedule of a complete plant with all the Bühler, and of course we also can integrate third-party components, which you maybe buy from any other competitor. What are the features? Our system, we always deliver turnkey, so we will not get an empty software. Maybe that's also one of our USPs, because we produce these machines and we know from all of these machines what needs to be focused on the maintenance topics. With that, you get a clear availability with detailed OEM maintenance forms. So the maintenance plans, the spare parts are all preloaded. Then you can focus really to only execute the maintenance task. This generates also the certain reports, the consumed spare parts, the working times, and also the unplanned maintenance of the complete plant. That's also ready then for the EFS and the audit certification, where you have to display or to show the history that the maintenance task has been done to that and that certain time. I have followed 3 or 4 of these audits, and it's really nice to see what are the questions, and maybe also changing in the future, that they want to see more and more, maybe not only when you have done the job, but who has approved the job, or how much time you spend on this topic and so on. So what is then the benefit of such a CMMS system in general, not only about ProPlant? It's clearly the asset availability and the visibility that you see which machine has been maintained, what is the status, how is the health of these machines. This allows you also the workflow visualization, the automation in general, not only the connection, but also that you have a process, a procedure, how to maintain the tasks. This leads overall in general of an improvement that could be reduced the downtime from 5 to 20%. It's able to improve the labor cost, so the lifetime cost of such a plant or a sifter here, up to 18%. So it can extend the lifetime. Then in some cases, if you have a very good spare part organization, if you trust your people and you can work with them, you can completely eliminate the storekeeper. So up to 15 to 25% by reduction of the spare parts cost, when you have a good team or good organization, which everybody knows which parts they took off from the shelf and then they record it into the system. And in general, up to 5% utilization upgrade is possible with a proper maintenance organization together with a CMMS system. Our benefits again here, ProPlant will tell you exactly what you have to do and when you have to do it. How you should do it, of course, that's a bit different, because then you need some papers, but in the manuals are step-by-step guidance also followed in. In combination with automation, that's what I mentioned before, ProPlant goes into the maintenance 3.0 section, especially with a Bühler software, where Mercury or Wincos R2 is available, then you really just do it on the maintenance tasks with ours. You have a complete history of all the investments. That's, by the way, what you need to accept the audit. You can improve your inventory management system. In the latest version, we have updated all the spare parts, so they are also available. You just need to create your own warehouse with QR codes we can print directly out of the software. And the biggest plus is, of course, that the data is there and you don't need to start a project to implement this by yourself over years or maybe months. Also, it's a lifetime, so the system will be always updated. All the clients would we have. The next release is on 5th of December, and they get some updates, bug fixes, extension of software, and also some new features. Good, let's step now to a different story to see now, let's say we use such a maintenance system. So our clients use the Pro Plant. They carry it on the maintenance task while using the system. So they generate a lot of metric data, such as numbers for maintenance works on different levels of equipment and operation sections. So what we did last year, also during that pandemic time, we did a data science project together with our colleagues here from data science team to get the full potential and to see the key performance indicators of the maintenance tasks, just by looking on the maintenance data and not sensor technology, and also not on the production data, which is maybe then coming from the PLC or the automation software, just on the maintenance tasks. So we did a study here. We created a new tool that will be called ProPlan Insights. It is an add-on to the existing system, which allows you to see the KPIs of your preventive and corrective maintenance tasks. The software will get two functions, an overview function, which you can do then some comparison, especially if you have multiple plants or multiple lines, mill A, mill B, mill C, line 1, 2, 3. You can compare them together. And it will be also an insights function, a bit more deep, and evaluation, where you see, for example, how my maintenance grows or reduces over the last years. When we start with the insights functions, you can see this is a customer that has 3 plants. In general, just to see how much task they do, and you can see here that one of these plants is already doing 55% of all the maintenance tasks, where the other 2, which maybe are also smaller, has about 25 and 20%. Now, to bring this in a relation, that's also very nice KPIs to see the PM, the preventive, the planned maintenance, against the corrective breakdown. We see that these 3 plants still a bit struggling. They have about 45% breakdown on corrective maintenance and 55 planned. So it will be always 1/3, it will be the best way. And we also saw some opposite where they do more corrective maintenance, but here focus really on that side. You can break it down to the operation sections. What is operation sections? The lines, what we have in the plant. So they're struggling here the most of the time in the flat storage. What we see over 3,000 tasks done the last year. Break it more down to the machine types. This is now in the Bühler language a bit more easy to understand. Top 10 machines, and we see here LBCA chain conveyor, which is over 2,500 times done. So that's really something which is maybe in pain for them. Let's go deeper to see how a maintenance organization or development is in general. This is the heat map of that 3 plants. So it was installed around 2015. And this is also something we should mention by implementing such a software, that maybe this will take time. It will be a long-term investment that will maybe not fully operate in the first year, and you get maybe after 2 or 3 years. What we see here at 2018, the data is very nice. From here on, we can start in doing this maintenance 4.0. But if you have no data, there is no evaluation possible. Another methodic, what is also very common, is a heat map. What is a heat map? A comparison, for example, from the machine types against the operation sections or the lines. And you remember this machine which we saw before, this LBCA. We see that this is struggling a lot, so over 300 tasks, but not in every section. So we see here the most pain is in the flat storage. So we should really focus then on that and maybe replace this machine or fix it, whatever. The next function is the insights function. This is the more deep dive function. So here I see one plant, I compare it with my own benchmark. You see here, this is the benchmark line. And these are the jobs they did in the last year, just at the moment on a very low level on the jobs. So what we see here immediately, that always the months of April, let's say from March to May, are dropping the maintenance tasks up to maybe 100 jobs, and then increasing in June. So there are two possible explanations for that. Either there is the seasoning time or Ramadan. Let's maybe look on the other three plants as well. And what we see here are clearly May and June looks like there is not only for that plant, but for all the three plants that they are not focusing more on the maintenance task. But June and October looks like these are the peaks. And here to find out this data, and then you can also break it down, of course, on corrective or preventive maintenance to filter really to see where are my pain points. Stepping one step ahead, going a bit more into detail. When we speak about preventive maintenance, you maybe know this term MTBR, mean time between repair. That's also a very common KPI in the maintenance language. What is that in general? The time between a repair, as you can see here, also here a benchmark, but this is my time I need in general over the year, so 140 days. And the benchmark is here. Now, as long as the benchmark and my time is plus minus, let's say 10, 15%, everything is good. Here also I'm better than the benchmark, but as long as these are related closely together, it looks that we have a good preventive maintenance planning. The same, then you can break it down, of course, on the line. So from machine going up, here the dosing, intake, storage, you see some of time, or most of the time we are much better than the benchmark. On some other topic, for example, the flat storage here, maybe I can focus a bit more. Now let's look on the opposite. Opposite of MTBR is MTTR, mean time to repair. And you remember before we had this line, this LBCA, what we see here, that this machine in the corrective maintenance, which they have recorded by themselves, is over 2 or 3 times higher. So this shows me clearly that either we need to find a very good proper overhaul, retrofit, or maybe this machine is really not so good developed. That's also, but just using the maintenance data, you figure out this kind of information. The others more or less look good. Sometimes we are okay, but if you see that 2 or 3 times higher in mean time between repair, that's really an indication for us that maybe the life cycle and labor costs are not more under control. Good. This ProPlan Insights is now available for all ProPlan customers, of course, starting from also 1st of November. It is a portal. We call it in the meantime ProPlan Insights Alpha because it's still not fully developed, but it will be sure also integrated into Bühler Insights platforms. Yeah, if you want to have access, please let me know. You will be also introduced later by the release letter when we update it next month. Good. Now let's go to another case study, which is more easy. I talked a lot of data now. Let's look on the future. Maintenance 4.0. Mobile. Why mobile? Very high demand, especially from some of the customers I have seen here in the group. Paperless. Now everybody wants to be digital. Paper is going away. That's right. It also suits somewhere in the sustainability of paper waste. Here you see how much paper one A4 is consuming of water. It's amazing, huh? You keep the history. Last year we saw digitalization time is now. Access to the documentation, it is also an add-on, so you don't need to have it, but it's also possible. And especially for your region, what is very important that a maintenance software, let's say on a tablet, needs to be offline available because sometimes you don't have internet. I know many customers which have some plants in the ports and you have to maybe struggle with 3G connections or maybe nothing. So somehow you should also use it offline. So this was the prototype we introduced in 2019 here on the networking days, showing here the maintenance procedures, what you have seen already in other systems, digital. Here is the maintenance overview. Then, for example, here the spare parts which you can use or are linked to the inventory system using also barcode technology. I think that's the future also, not RFID or maybe something similar. QR code is what we are focusing these days. and this kind of way to do the maintenance tasks, either on a tablet, which is maybe easier to use, but also we saw that many customers are looking on smartphones, and that's our common day work life, what we all have. So why not bring it also directly on the smartphone to do this maintenance KPIs and not using it more in front of a computer. This is the first outlook, how the ProPlan Mobile will look like. Gentlemen, ladies and gentlemen, stay tuned. Next summer, networking days, we will go release the new ProPlan Mobile application on Maintenance 4.0 industry. Good, thank you very much. That's it from my side. I hope I could open the mind in general about maintenance, show you what is current, what is the future, and also maybe give also some advice from my experience over the last 10 years.
Thank you, Blerim. Very interesting insights and maintenance future, what will come. Please, to the audience, place your question or your questions.
Mm-hmm.
I will start, Blerim. You mentioned CMMS, Computerized Maintenance Management System.
Mm-hmm.
It's mainly data-based. Question, what is the supplier providing and what does a miller need to do to implement?
The supplier in general, I mean, there are many or plenty of maintenance systems around in the market. You can get them standalone from very cheap. You can get them integrated in SAP or similar ERP system. What the supplier usually is provided is the framework of the system, maybe the database, the templates, this kind of stuff, and the mill needs to integrate all the knowledge into a system like ProPlan or CMMS. That's also the biggest challenge, Martin, to be honest, because maybe some of you guys already has done this kind of action task that will take a lot of time and effort, and also here the consistency, which is maybe lacking over time when you have to feed a system, maybe practice then also maintenance and do the planning in the same time together with the operation. So it will be a challenge, I would say.
But you're saying that the documentation is part of the CMMS. Is that correct?
Absolutely, yes. The documentation, there are two documentations. One is the documentation to maintain, I mean, the spare part catalogs, for example, or the maintenance plans, or in general, the books, the handbooks of the machine and equipment. And the other part, which is more and more coming, is the documentation for traceability for the auditors, EFS, ISO certifications, they approve to show that the maintenance task has been occurred or executed at the right time. This is more and more coming. So,
from your point of view, what are the challenges of implementing such a CMMS system?
Yeah, I think I mentioned it a bit before. I think it is really the administration effort in the beginning and the consistency after, let's say, the first 3 or half year, that you are still motivated to feed empty software, to bring in all your information, knowledge, which you have in mind, this especially with older or easier softwares or simpler maintenance softwares, or maybe also combined systems like today's they are called TQM, Total Quality Management System solutions, into a bigger or higher ERP system. That is also maybe a little bit then increasing your effort. And also sometimes I have seen customers telling me this is going to be a never-ending story, that they started implementing that and they are maybe not finishing. To my opinion, keep it simple, ladies and gentlemen. Start and focusing in the beginning on the efficiency. So that means doing the things right, which is short-term related, and later stick to it on the effectiveness. So do the right things. That means long-term based. I think that's the success or the golden term to implement such a system.
Thank you. Blerim, any question from the audience? I see nice presentation. Does the system take into consideration the monitoring of parameters when deciding we need to repair, or it works depending on given data? That's from Fares.
Thank you, Fares. I think it's both possible, but to my opinion, the parameters on the operation should be linked directly on an operation software like Wincos or Mercury. So the condition monitoring on live, I believe that should be really showing directly, because the maintenance software maybe is not every day in use, especially when you work shifts. You know, the operators in the night shift, maybe they don't open the maintenance software, they don't see this information, or they see it too late. That's what I think should be our focus, to say what is really preventive, planned, corrective maintenance, or maybe also predictive, and what is really operation data. And to this speech, my colleague Dirk Eifert will show you the next days, and also Alexis, he will also give you some more insights, which maybe clarify these two kind of routes.
Thank you. Are there some further challenges in future, Blerim? Looking a bit next.
What do you mean in general, or?
In general?
In general. I think I mentioned before a little bit that I see more and more a gap between the mechanical knowledge that people, or the younger generation, what is that now, Generation Y, I think, or Z, is not more focusing really on them, how to say, on the physical work, that they are more focusing on computer technology. I'm also using everyday computer technology, but I still trust what I see, or what I touch, or what I see in front of me. And to my opinion, believing that much in digitalization, maybe that brings me also not out of my comfort zone, that I always trust in data, in sensor data, and I never see the machine more in front of me. To be honest, it scares me a little bit, that I just look on data and never see the machine screaming or scratching in front of me. That's a bit what I think it will change, surely, that we just use data, and data is king, and we lost a little bit the reality, or the physical way. That's what I think. But maybe that's also because I'm a mechanical engineer. That's a mindset, maybe.
So your message is we still need qualified staff, qualified mailers, qualified maintenance.
Try to keep them. That's many customers I saw that they're maybe hiring, they try to find some people. It's not possible. Some of them maybe then hire the internal people, which is then doing this job, which is not really his intention. That's really the challenge, that the knowledge is going to be lost. So because we have now everything, we have open internet, we have open sensors, we can see the data, but we're not doing it more by ourselves. We're losing the physical work.
Good, thank you, Blerim. Other question?
Yes, Mr. Martin, we have a question sent to us directly. I will just read it. Yes, I'm starting please. A small mill, 60 tons. At what stage do you recommend to start CMMS? All my machine will be new, from Deborah.
Thank you very much. A 60-ton flour mill, which is very small, I will guess he will maybe have about 100 assets. Also, here is the question, if he is going to implement a CMMS in general, or maybe he takes some free version, because I think for smaller companies or smaller plants, that the CMMS is not getting an overkill. Maybe it makes sense to start first using his Excel templates. I mean, taking all the information which he needs to take care, and then maybe start with a calendar, simple, maybe on Outlook, and getting these preventive maintenance reminders. And if that gets too much, start later thinking about maybe buying a CMMS software. I know smaller plants or smaller mills, maybe they don't have this budget to implement such a CMMS software. Maybe better, my advice is to start using it on a simple calendar and see how that grows over the long term. That's my advice for him.
Good. CMS can be implemented to any kind of plant, any age, younger or older. Is that correct?
Absolutely, yes. It is. I mean, when they are older, of course, there is the question of the retrofit, how much machines and assets has been changed. The right implementation time after CMMS, to my opinion, is, let's say, after you make the commissioning, or let's say the plant is smoothly running and the organization is well adapted. When this is happening, let's say after 5 years, it's very easy to implement anything else. You just need to stick on the maintenance plans from the OEM supplier, and then I can guarantee that will really lead to a success.
Perfect. Any further question from the audience?
Nothing received on chat, Mr. Martin.
Okay.
Martin, can I maybe just give a general advice about maintenance? Because I see that many times when I go on site that always they ask me, what is more important? Is lubrication important? Is cleaning important, or maintenance? And if I stick to these rules, what I found out the last years, in my opinion, maintenance, lubrication comes first, after cleaning, after maintenance. Lubrication, because abrasive components like bearings, chain conveyors, they need the balsam to ensure short-term operation for the general function, okay? Cleaning is very key to avoid pest control, especially in Middle East region. And maintenance in general, the word maintenance is focused on long-term operation to avoid that the plant is running also after 5 years. So stick just to this. This is to my, if you do nothing, if you don't want to implement the software, cleaning before lubrication, before maintenance, before cleaning. That's the golden rule, to my opinion, or experience.
Good insight. So the third day we shall be also on components lubrication. Now I got
absolutely. I have seen that. I'm very happy to see this presentation. What is coming on in this direction?
We got another question in the chat. What are the requirements for the system to work efficiently?
I mean, the question is related to the maintenance software, right? Or the CMS software.
Correct.
Mm-hmm. Yeah. What is the requirement? If you use a system and you make it by yourself, I think the efficiency, I've seen many softwares which are created by the companies themselves. They use an Excel template and they have certain connections. Maybe this user is related also, that the speed is getting lost. So the system should be somewhere fast, or you could use it in an efficient way. And also it should be related that you see really that what is your necessary, and you don't have too much information. Keep it simple. What I say, short term first before long term. Keep the data which you have to focus. I have to grease here the flour mill. Okay, let's do that. That's my purpose for today, and not overestimating or overkilling the software with all of the others. Keep it simple first, this, and stick to that. If you have plan A, gentlemen and ladies and gentlemen, keep to your plan. Do it for long term, let's say 3 to 7 years, before you think about plan B or even have a plan C in mind. You stick to that, believe it, go. If you see after 3 years, okay, that was not the right decision, then you maybe change mind. But before, I see these days more and more tools are coming in, and more philosophies are changing, especially on the board or on the management. And if we can follow always these changes, we'll maybe never achieve anything.
Thank you, Blerim.
Thank you all.
I see no further questions.